يعطيكم العافية طلابنا، كيف أخباركم؟ إن شاء الله بخير. رح نبلش اليوم معكم درس جديد اللي هو Thales Theorem. بتمنى تحطوا كتابكم الأهلية قدامكم، كتاب الأهلية and open your books on page 84 and 85. Okay, we're going to start with the chapter of Thales Theorem. Okay, be ready, put your books. I'll pause this video and wait you till you put your books and open them on pages 84 and 85. Now, are you ready? Let's continue. Third property. Let D and D prime be two non-parallel straight lines. A, B, C are 3 points of D, and A prime, B prime, C prime are 3 points on D of D prime. As you can see in the figure, A, B, C on D, and A prime, B prime, C prime on D prime. If AA prime, BB prime, and CC prime are parallel, then we can say AB over AC equal A prime B prime over A prime C prime. Okay, this is very important. Pay attention to it. We use it in trapezoids, and we are going to explain it in triangles. If the two lines D and D prime intersect at O, so we have a triangle OBB prime, and we have a triangle C, then OA over OB equal, then OA over OB equal OA prime over OB prime. As you can see here in these two figures, in this figure, OA over OB equal OA prime over OB prime. And in this figure, OA over OB, they are on the same line, the 3 points OA and B are on the same line, is equal to OA prime over OB prime, and the 3 points A prime, O, and B prime are on the other line, okay? Now pay attention to this well. You can see them also on your books on page 85. Thales theorem in a triangle. This is the general form of Thales theorem. Given a triangle ABC, as you can see here, we have triangle ABC. The line D cuts AB at B prime and AC at C prime, okay, such that the line D is parallel to the line BC. The line D is parallel to the line BC. So, given a triangle ABC, the line D cuts AB at B prime, and the line D cuts AC at C prime. If D is parallel to BC, as you can see here, the symbols, D is parallel to BC, then we can say AB prime over AB. Look at here, we start from A. AB prime over the small one, the small one, over the big one, AB, is equal to AC prime over AC, the small one, over the big one, is equal to B prime, C prime over BC, the small one, over the big one. This is the general form of Thales theorem in a triangle, which is the most important and which is the most useful, and this one is going to use it more than any other formula in this chapter. So we have ABC is a triangle. I repeat again, line D cuts the two lines AB and AC at B prime and C prime respectively, such that this line D is parallel to BC. Then Thales theorem is the following ratio: AB prime over AB equal AC prime over AC equal B prime C prime over BC. As you can see here, when you start from A, look at these two ratios, A. These four segments are starting from the same point A. AB prime over AB equal AC prime over AC. Then, when we say that these two ratios are equal and they are starting from a point A, the same point which is A, then we can continue that B prime C prime is parallel to BC. B prime C prime is parallel to BC. Let's take an application. Application 1, also it's on page 85. ABC is a triangle such that AB equal 4 centimeters, AC equal 5 centimeters, and BC equal 6 centimeters. Okay, this is the given. B prime is a point of AB such that AB prime is 3 centimeters. Also, we have the measure of this segment AB prime. The parallel to BC. So here we have parallelism. The parallel to BC in the line drawn from B prime parallel to BC. So B prime C prime is parallel to BC. So we can apply Thales theorem. It's a very important condition. It's a very essential condition to have parallelism. Two lines are parallel in a triangle to apply Thales theorem. So the parallel to BC drawn from B prime cuts AC at C prime. And we continue. Calculate the what's wanted here. The ratio AC prime over AC. The segment AC prime, and we should calculate AC prime over AC, this ratio. Okay, and then the segment AC prime, we should calculate it. Also calculate B prime C prime over BC and the segment B prime C prime. Okay, let's start with the solution. Solution of application 1. So this pose was for you to think about this application and try to find a solution to it. Solution. We have these measures are given. Okay. We have also B prime C prime is parallel to BC. The measures and parallelism. Then we can apply Thales theorem. Applying Thales theorem or Thales property. AB prime over AB equal AC prime over AC equal B prime C prime over BC. And it is required to find first the ratio AC prime over AC. We have these sides AB prime, which is 3, and AB, which is 4. If we substituted AB prime with a 3 and AB with 4, we get the ratio AB prime over AB equal 3 over 4. But also we have that AB prime over AB equal AC prime over AC equal B prime C prime over BC. Then equals of equal are equal. AC prime over AC equal AB prime over AB equal 3 over 4. So the ratio AC prime over AC is equal to 3 over 4. Okay, this is the first required ratio, which is AC prime over AC, and it is calculated to be 3 over 4. Okay, now it's required to calculate what do we have on the figure, AC5. It's required to calculate AC. So we, instead of AC, we put its value, which is 5, and since AC prime over AC equal 3 over 4, instead of AC we put its value, which is 5. Then we get AC prime over 5 equal 3 over 4. By cross multiplication we get that AC prime is equal to 15 over 4, which is 3.75. Then AC prime is equal to 15 over 4, or 3.75. And we calculated AC prime, which is 15 over 4. Now we should calculate the ratio B prime C prime over BC. B prime C prime over BC is equal to AB prime over AB equal to 3 over 4, which is also AC prime over AC. And finally, we should calculate B prime C prime. Finally, now we should calculate B prime C prime. We take the ratio B prime C prime over BC, which is equal to 3 over 4, and we substitute BC by 6, since BC is equal to 6, and we get B prime C prime equal 18 over 4 by cross multiplication. Okay, 18 over 4, which is 4.5, or 9 over 2, which is 4.5. So this is the solution for application 1. Application 2, also it's on page 85. We have the triangle ABC, the adjacent figure. ABC is a triangle, B prime C prime is parallel to BC, and B prime C prime equal 2 centimeters. And also it's given that AB prime over AB equal 1 over 3. So here, let's think about it. Think about it. I'm gonna give you some time to think about it. Okay? Remember, B prime C prime is parallel to BC. There is parallelism. Then we can apply Thales theorem, and we have the ratio AB prime over AB is equal to 1 over 3, which is so helpful. And we have B prime C prime equal to centimeters. Okay, let's see what is required to calculate in this. Calculate first AC prime over AC. We should calculate the ratio AC prime over AC and the side BC and the side BC. Okay, as you know, I'll give you a hint. B prime C prime is parallel to BC. Think about it. What do we apply? Yes, I'm hearing you. We apply Thales theorem, and Thales theorem here says AB prime over AB equal AC prime over AC equal B prime C prime over BC. Okay? First, let us find AC prime over AC, which is wanted to be calculated. We have B prime C prime is parallel to BC. Apply Thales property. AB prime over AB equal AC prime over AC equal B prime C prime over AC. As you can see here we are starting from A. These four segments are starting from the same point, which is A. So we can continue this theorem, our Thales theorem, to say that B prime C prime over BC, which is AB prime over AB equal AC prime over AC. These four starts with the same point A. We can continue to say is also the ratios are equal to B prime C prime over BC. And we have the ratio AC prime over AC equal 1 over 3. So AB prime over AB equal 1 over 3 by what equals of equal are equal, and also 1 over 3 equal AC prime over AC equal B prime C prime over. So we calculated AC prime over AC which is equal to AB prime over AB equal 1 over 3 by Thales theorem. Now it is required to calculate BC. Using the previous ratios, we have AB prime over AB as it is given 1 over 3, AC equal AC prime over AC equal B prime C prime over BC, which is Thales theorem. Now we are going to calculate BC. We have B prime C prime is equal to 2. We take this ratio 1 over 3 and this ratio B prime C prime over BC, and instead of B prime C prime we put 2 and we do cross multiplication to get what? BC. We get 1 over 3 equal B prime C prime over BC. We substitute B prime C prime by 2, and now we by cross multiplication BC is equal to 2 over 3. 2 times 3 over 1. BC is equal to 6 centimeters. This is application 2. Let's take a look for some extra exercises. This exercise is not found in your Ahliya book. It's a supplementary one. In each of the shown figures, as you will see now, figures 1, 2, and 3, we should calculate x and y, where x and y are measures of lengths in centimeter, x greater than 0 and y greater than 0, showing your work process. We should show our work, okay? Okay, let's start a little bit here. We have here MN parallel to BC. Then Thales theorem says AN over AC equal AM over AB equal to what? MN over BC. We started from A and we can continue to say that's equal to MN over BC. The same as here. So I repeat, AM over AB equal, AB over AM equal AC over AN equal MN over BC. Sorry. Let's start again. AN over AC equal AM over AB equal MN over BC. If we start with that, إذا بلشنا بالصايد الكبير كلهم بيكونوا الكبير على الصغير، كبير على صغير، كبير على صغير، كبير على صغير. إذا بلشنا بالصايد الصغير كلهم بيكونوا الصغير على الكبير، الصغير على الكبير، الصغير على الكبير. يعني إذا هون AB، إذا قلت أنا بلشت AB over AM كمل AC over AN وبكمل شو BC over MN. إذا بلشت بالصايد الكبير اللي هو AM over AB اوكي equal to AN الكبير على سايد AC اللي هي الصغير equal to MN اللي هي الكبير على سايد BC اللي هو الصغير. The same as here AM over AB equal AN over AC equal MN over BC. بلشنا بالصغير على الكبير. AM على AB الأكبر AN على AC الأكبر equal MN على BC الأكبر. And remember there should be parallelism, and here MN is parallel to BC. The same as here in the part 3. Also we have AM over AB equal AN over AC equal MN over BC. Since we have MN is parallel to BC, we are going to take each case and to state the given exactly and start the solution. The above figures are not of real dimensions. These measures are not real dimensions, okay? To be sure. Solution of exercise 1. In each of the three cases, in general, not to repeat it in each part, we have MN parallel to BC, so Thales theorem, AM over AB equal AN over AC equal MN over BC. As you can see here, these four segments are starting with the same point, which is A, so we can continue it to say MN over BC. In part 1, AM over AB equal AN over AC equal MN over BC. Okay, what do we have here? AM over AB, we start to replacing them. AM is equal to 4.5, over AB is X, AN is equal to Y over AC 2.4, MN is equal to 5 over BC, which is equal to 3. Then we start. We take this ratio and this ratio. We have one unknown, which is X. By cross multiplication, we get 5X equal 13.5 and X equal 2.7. Then, to calculate Y, we take this ratio and this ratio, and by cross multiplication also we get the value of Y, as you will see here. So Y over 2.4 equal 5 over 3. Then by cross multiplication, 3Y equal 12, Y equal 4 something. This is the first part. The second part, let's move to the second part. The second part, the same. AM over AB equal AN over AC equal MN over BC. And this triangle, let's check the given. AM is X, MB equal 1.2, AN equal 3.6, and NC equal Y. We have MN equal 3.6 and BC equal 4.5. We start replacing the values of the segments in the ratios. AMX over AB, this is AB from A to B, is equal to X plus 1.2. So instead of AB, we put X plus 1.2. AN equal 3.6, AN equal 3.6 on the figure, and over AC is equal to 3.6 plus Y, which is AN plus NC, 3.6 plus Y, equal to MN over BC, which is equal to 3.6 over 4.5. This ratio, 3.6 over 4.5, is equal to 0.8. So we can use this ratio and this ratio to calculate X, and we can use this ratio and this ratio to calculate Y. Let's see the solution. This time is given to you in order to find your solutions or to do your calculations. So here now we take this ratio is equal to 0.8 and X equal, we do cross multiplication and calculation X equal 4.9, and also we take this ratio which is equal to 0.8 in order to calculate Y. So now we get X and Y by the cross multiplication. And the third example, remember AM over AB equal AN over AC equal MN over BC, Thales theorem. Let's see, let's check what do we have in this figure. We have AN equal 7.2, NC we don't have it. We have AC equal 12. On this side we have AM equal X, MB equal Y, and MN we don't have it. We have BC equal to 5 centimeters. Okay, let's start by replacing the values in the ratios. In the right triangle ABC, we can calculate AB square by Thales theorem. AB square equal AC square plus BC square, which is 12 square, plus 5 square, which is 169. So AB equal 13, and we calculated AB. Now we can replace the values of the segments. AM over AB equal AN over AC. We start by these in order to calculate X. AM is equal to X is equal to AN over. So AM equal X over AB calculated here equal 13, equal to AN is given 7.2 over AC 12. By cross multiplication we can find the value of X equal 13 times 7.2 over 12, and X equal 7.8. Now let's see how we are going to calculate Y. Don't forget the Thales theorem. Now we have AB equal 13 centimeters, x equals 7.8, so y is equal to 13 minus 7.8. Since we have AB equal AM plus MB, then 13 equals 7.8 plus y. Since we have MB equal y and x is calculated to be 7.8, so y plus 7.8 is equal to 13, and y is equal to 13 minus 7.8, y is equal to 5.2. Thank you for watching. See you in another video.